Example 12.9 is a word problem. Let's take a look at the narrative. The narrative can be found from the first sentence all the way to the sentence right after the equation, and then part A and B are going to give us the question. But before we go on to the question, we really need to make sure that we understand the narrative and what's going on here. It says a ball is thrown upward and outward from a height of 6 feet. The height of the ball, and then it has comma f of x, comma in feet. So I'm going to go ahead and underline all of that. Height of the ball, comma f of x in feet. And this is important because f of x represents the y value when we think about the graph in the Cartesian coordinate plane. Now specifically for this problem, the f of x is meant to represent the height of the ball. And it says here it can be modeled by the equation, and then the equation is given to us. In the equation, you have f of x, which is your height, or your y value, and then your height is going to be equal to this expression that is quadratic. And in that quadratic expression, we have x's. So now the second little bit of this narrative, what happens after the equation, then explains what x represents, where x is the ball's horizontal distance in feet. So it gives us some insight here as to what the different variables in the equation represent. X is the horizontal distance of the ball, and f of x represents the height of the ball. So now that we have that understood, let's take a look at the actual question. It says, what is the maximum height of the ball and how far from where it was thrown does this occur? So maximum height makes me think of an f of x value. How far from where it was thrown makes me think of a horizontal distance, x. So it sounds like I'm looking for both an x and an f of x value, or I'm looking for both an x and a y value. But the key here is to see there's the word maximum. So looking at the equation a little bit more closely, I can see that the a value is negative 0.8. That tells me that I'm talking about a parabola that's going to be opening down. And sure enough, if my parabola opens down, there must be a point where there is a relative maximum. So that's the point that we're looking for. We're going to end up calculating the h and k for that point. H is going to represent the how far from where it was thrown, and then the k is going to represent the maximum height of the ball as it's going through its path. So let's go ahead and start working on that. For part A, we're going to say h equals negative b over 2a. Here we have 2.4 to fill in for b, and we already saw negative 0.8 is what we'll substitute in for a. So that'll be negative 2.4 divided by negative 1.6, and that's going to end up giving us the decimal 1.5. And we also saw that the unit for x, which is what h is, it's an x value for the vertex, is supposed to be feet. So 1.5 feet is what we calculate there. Then we want to calculate k, and k is going to end up being f of 1.5. So let me plug in 1.5 into my quadratic expression. And with this, if you have a calculator handy, you should be able to just type into the calculator as it is, and you will eventually get the value 7.8. And that's not an approximation, that is exact. So we have exactly 7.8 feet for the value of k. So what we'll do is write a sentence to answer the question, including these two values. So let's start with saying the maximum height of the ball is 7.8 feet, which occurs at a horizontal distance of 1.5 feet. And that should be it. That answers the question, uses both the calculations we came up with. So that's part A. Now part B says, how far does the ball travel horizontally before hitting the ground? So going back to that picture up there of the parabola that opens down, what I have depicted, if I go ahead and put a ground level in here, which we can think of this ground level as being the x-axis, then I'm representing this as a ball being thrown from the ground up to a maximum height, and then it ends up falling down and hitting the ground over here on the right. So presumably everything goes from left to right, where x's are increasing. But the idea is the ball is supposed to be starting from a height of 6 feet. So really the y-axis is probably going to be a little bit more right here, so that way the actual starting point on the y-axis would be up here at a value of 6. So we can't get away with just doubling the x value from part A, because that would only get us over here, and we want to be able to get all the way down here to the ground. Now what I can tell you about being at the ground here is that you're talking about an x-intercept. So that's going to be some x value comma 0 for the y value. Every x-intercept has to have 0 for the y, otherwise it can't be an x-intercept. So that ends up being our ticket to be able to start this calculation. We're going to say let f of x, which is the y, be equal to 0. And then when we do that, we will now have the equation 0 equals negative 0.8 times x squared plus 2.4x plus 6. Now you'll want to go back and review the quadratic formula. And the quadratic formula says that if we have a quadratic equation where it is standard form equal to 0, which is exactly what we have something that looks like ax squared plus bx plus c equal to 0. So if we have something that looks like that, then we are permitted to use the quadratic formula, which says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And sometimes students will have the misunderstanding that the quadratic formula is just sort of this end-all be-all, can do everything with quadratics. And in reality it is very powerful, but the only time we are allowed to use it is if we have a standard form equation equal to 0. And that's what we have here. So I'm going to go ahead and erase the standard form equal to 0, but in its place I'm going to write down the appropriate values for a, b, and c. So we would have a is negative 0.8, b is 2.4, and c is equal to 6. So we're going to let those values be defined for us, and we're going to use them in the quadratic formula. So now on to the simplifying of the quadratic formula. Let's see, negative 2.4. Actually, we're not simplifying yet. We're just getting to the plugging in part first. We'll get to the simplifying here in a bit. So 2.4 squared minus 4 times negative 0.8 times 6, all divided by 2 times negative 0.8. So I want to give you some tips in terms of simplifying the quadratic formula. You're going to want to do this in pieces. You'll start at the beginning of the numerator on the left-hand side. It says negative 2.4, so we're just going to call it negative 2.4. And then plus or minus, and then square root. And there's this big expression that's underneath the square root. Go ahead and calculate what all of that is supposed to be. And if you want to pause the video so that way you can do the calculation yourself, go ahead and do that now. The value that we should calculate underneath the radical is going to be 24.96, and that's not an approximation, that is exact. And then go ahead and simplify the denominator, and you'll have negative 1.6 down there. So after that, the next simplification is going to be to actually take the square root of 24.96. So go ahead and do that. When you take the square root of 24.96, you should find that your answer is really close to being 5. It's something 4.99, 8 something. It's very, very close to 5. And so I'm just going to replace my equal sign and I'm going to turn it into a approximation sign and call it negative 2.4 plus or minus 5, all divided by negative 1.6. So what this is going to end up doing for us is giving us some calculations. We get some answers to our equation. So once you apply your plus or minus, 1 plus 1 minus, you should get two answers. You're going to get negative 1.625, and I believe the other one is 4.625. Now, when we're talking about throwing a ball upward and outward, we're talking about it moving in front of us in a positive direction. Behind us would be a negative direction. And the narrative tells us it didn't go behind us, it went upward and outward. So we can say that the negative x value, the negative horizontal distance, is not going to make sense with our physical system, although the parabola itself, if we were to graph the whole thing, would extend beyond the actual physical limitations that we put on the ball with the ground and the starting point. So really we're going to focus just on the answer 4.625. And we're also told that we need to round the answer to the nearest tenth. So I'm not going to use the entire 4.625, I'll use 4.6. So to answer the question, we'll say the ball travels horizontally about 4.6 feet. Since we're talking about an approximation, we're rounding, we'll use the word about there. About 4.6 feet before hitting the ground. And that finishes part B.